To start today, you need to write this warm-up down where you have space. You can use the cover of your packet or find a blank page in the packet. Once you write it down, pause the video and try to factor. Okay, so all of three of these problems involve a greatest common factor, which means we want to divide out the greatest term that can divide evenly by all the terms. So in A, I noticed that 3, 9, 27, and 81 are all a multiple of 3. So they can all divide evenly by 3. And then as far as the x terms go, this last term has just x to the first power, and all the other terms would divide evenly by that. So when we factor out the greatest common factor of 3x, we're rewriting this as a multiplication problem. You can envision that each term is being divided by that GCF, and that would help you reduce. So 3 divided by 3 is 1. X to the 5th divided by x is x to the 4th. 9 divided by 3, x to the 4th divided by x. That law of exponents is subtracting the powers when you are dividing the bases. 27 divided by 3, x squared divided by x, 81 divided by 3, and x divided by x. Okay, now for part B, 8 and 2 divide evenly by 2. X squared and x divide evenly by x. And when we divide, so 8 divided by 2 is 4, x squared divided by x. 2x divided by itself is 1. So again, if you want to, underneath each term, write what you're factoring out, the 2x divided by 2x, that doesn't disappear to 0, that divides and simplifies to 1. All right, so now part C, there's two different ways you can factor a greatest common factor here. We could divide evenly by positive 5. Or you could divide by negative 5. And then that would just change the positive negative signs in the binomial that's remaining. So the reason we wanted to review this type of factoring one more time is if you turn to page 16, we are going to discuss how to find wholes in rational functions. We've done vertical asymptotes. We will do that again today, but for now, we're going to focus on the new information of the whole. So a whole is a removable discontinuity. And here's how we find the whole coordinates. First, you have to factor everything. We want to factor everything so that we can see what we're dealing with. And sorry, I lost my train of thought. Okay, so if the factors simplify and divide to 1, we've removed those factors. Those are the coordinates of the whole. If they don't divide to 1, if we are remaining with a factor in the denominator, that would produce a vertical asymptote. We will get to horizontal asymptotes once we reduce our equation. All right, so let's factor A, and that will make these two criteria make sense. Pause the video, factor the numerator, factor the denominator. Okay, so what multiplies to 2 that adds to 3 is x plus 1 and x plus 2. The denominator is the difference of perfect squares, so that's x plus 2, x minus 2. And so what we have here is the x plus 2 factor divides to 1, right? Those reduce. So the whole, so if I look at this last bullet point, the factors that divide to 1 produce the whole. So the x coordinate of the whole is going to come from when x plus 2 equals 0. So the removed factor gets you the x coordinate of the whole. Let's add that. The factor that divides to 1, when that equals 0, that's the x coordinate of the whole. So we can solve this and we get x equals negative 2. Now, wholes are coordinates. It's an x comma y. So to find the y coordinate, right, because now we've got negative 2 comma something, we're going to look at the compressed function, the reduced function here, once we've removed that factor. So we're left with x plus 1 over x minus 2. So this is our new r of x. To find the y coordinate, we're going to replace the x value into the compressed function. So we're going to find r of negative 2. We take this x coordinate and input that for the x values. So we're left with negative 1 over negative 4. And a negative divided by a negative is a positive y value of 1/4. So we did it. We found the coordinates of the whole for problem A. Now let's go and find the vertical and the horizontal asymptotes. So the vertical asymptote, that's going to come from the remaining factor in the denominator. So when does the denominator equal 0? That's when x equals 2. So there's our next answer. The vertical asymptote is at x equals 2. And then the horizontal asymptote, we're going to compare the degrees of the numerator and denominator of the compressed function. We already did the work. Let's use it. So I see that both exponents are a 1, which means we divide the leading coefficients. So a horizontal asymptote, that's going to be y equals 1 divided by 1, which is just 1. Okay, we did it. We did problem A. We found the whole, vertical, and the horizontal asymptotes. Let's try B. Factor everything that can factor. Pause the video and do that. So the numerator has a greatest common factor of 2. So I divide out the 2. The denominator, what multiplies to negative 5 that adds to negative 4 is going to be positive 1 and negative 5. So take a moment and decide what factor would produce the x coordinate of the whole. If you said x plus 1, that is correct. So we set that equal to 0. So this function has a whole when x is negative 1. Now with the compressed function, to find the y value, we're going to input x into the compressed function. Okay, so 2 divided by negative 6 reduces to 1/3. And we don't write a negative in the denominator. That looks bad, so we're going to put that in the numerator. And we get a y coordinate of negative 1/3. All right, so for the vertical asymptote, That's when the denominator equals 0 of your compressed function. So that x equals 5. And for the horizontal, y equals, when we compare our degrees, there is no x in the numerator, so the degree of the numerator is smaller than the degree of the denominator. So that creates a horizontal asymptote of y equals 0. Okay, one more. Pause the video and try part C from beginning to end. Okay, so I'm going to factor. The numerator is the difference of perfect squares. The denominator is a trinomial where a is 1. So we've got 7, 3, positive, negative. All right, so our compressed function is x plus 3 over x plus 7. The x minus 3 creates the whole. So when does x minus 3 equal 0? It's positive 3. Then we have to input that to the equation that we compressed here to get the y coordinate. 6 and 10 are both even numbers, so they reduce by 2, and we get a y coordinate of 3/5. Vertical asymptote is when the denominator equals 0. Horizontal asymptote, I'm going to compare the degrees. 1 and 1 for powers means divide the leading coefficients, which are both 1, so we get y equals 1. So for this last equation, I just want to show you what that would look like on an actual graph. So what I've created here is I typed in the equation. And so you can see we've got the horizontal asymptote right here at y equals 1. We've got this vertical asymptote. You can see the end behavior, the graph behaviors as you approach -7 from the left and from the right, approach that asymptote. And then over here at 3, the x value of 3, we have this missing point. That's the whole from that removed factor. Okay. Now, the last part before we get to slant asymptotes tomorrow is using the Algebra 2 knowledge of polynomial division. So this is a process that you did in Algebra 2. We are going to do a review. You had a homework assignment to review the 2 methods and tell your teacher with a little quiz your favorite one so that they know how to teach class. If you have not already done that, I think I have a reminder on the next page. Yes. If you have not already done that, it needs to be completed by tomorrow morning or tonight so that we know which way we're teaching you tomorrow. So here is the review of both methods. For number 1, I'm going to use long division. So we've got m minus 8 and then m squared minus 7m minus 11. Okay, so your first step is to have a division thought. We're going to take the leading terms. And so here's my division thoughts. What is m squared divided by m? M. And so when I put that up here in my quotient, in my answer, I line up like terms. Okay, so we have a division thought. We did that. Next step, multiply it back. So we go m times m and m times -8. And then we subtract. So both terms have to be subtracted from the line above. First terms add to 0, then I get 1m, and we bring down the -11. Okay, we repeat that. Have a division thought. Now I'm going to take 1m and divide by m. That's 1. positive 1. Multiply it back. 1 times m, 1 times negative 8. Subtract. And we have a remainder of negative 3. Now, the best part about asymptotes tomorrow is the remainder is not going to matter. But for our division purposes, we have a quotient of m plus 1. And then we have the remainder over the divisor, which was m minus 8. So for a pure division answer, it's quotient plus remainder over divisor. For asymptote purposes tomorrow, we're only going to care about the quotient, but that's for tomorrow. Okay, that's long division. Then the other method is a box method. So for number 2, to do this with box method, you're going to create, you guessed it, a box. And the number of rows comes from the divisor. So I've got x and positive 6. Then to create the columns, I start at this first corner and I take the other term here and I've got x squared, 5x is in the corner, and then I add a column for the constant of 3. Okay. The first term gets copied back into the box. And now our process is the same. Have a division thought. X squared divided by x. Because now with this, it's also called area method. If you do length times width, x times x, you get the area, the inside of that rectangle. Okay, then we're going to multiply back. X times 6. And we subtract, or if you'd rather think of it this way, this diagonal has to add to 5x. So 5x minus 6x is negative 1x. You can check, does this diagonal add to 5x? Yes. Okay, have a division thought. Negative 1x divided by x. Multiply it back. Then the remainder is 3 minus negative 6. So again, for our pure division purposes, we've got quotient plus remainder over divisor. So the quotient comes from this top part of your box method. Okay, more division tomorrow. Now your practice today is page 18. On your calendar for number 8, it does say just find the whole and the vertical asymptote. There is no horizontal asymptote. This one has a slant. We'll do that tomorrow. Okay, so now use the rest of the time to complete your homework.